To understand the electromagnet, it's helpful to take a moment to learn about its inventor, William Sturgeon. Sturgeon's life was dramatic and inspirational, although his hair and sideburns were, I think, regrettable. Take a few moments and learn why a poor shoemaker and soldier would invent the electromagnet and how it works. Ready? Let's go.
Electricity, 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 electricity.
William Sturgeon was born in 1783 to a poor shoemaker who treated him badly. When he was 10, his mother died, and a few years later, his abusive father basically sold him to another shoemaker who also treated him cruelly, and according to him, he lived a life of slavish drudgery. When he was 19 years old, Sturgeon escaped by joining the army. The army was good for Sturgeon. He found that the officers in particular were appreciative of his skill at fixing things, especially their shoes. He would also entertain the officers and fellow troops with amateur science demonstrations that he invented himself. Sturgeon then traded his services to officers for lighter duties and to borrow their books. Remember, at this time there were no libraries, and books were prohibitively expensive. In this way, he actually taught himself math, Greek, Latin, French, German, Italian, optics, and lithography. After 18 years in the army, Sturgeon retired and moved to the Woolworth district of London. His plan was to start a shoe store. For that reason, he contacted some officers who he knew from the military. However, many of them were interested in the latest developments in science and asked Sturgeon for help with their devices as well as their shoes. It was fortunate timing because in that same year, a man named Hans Christian Ørsted in Denmark had discovered the current in a wire moves the magnet in a compass. So at the time, everyone interested in science wanted to experiment with electricity and magnets. Sturgeon began to build scientific devices for his friends and focus on electricity and magnetism as it was the hot topic of the day. One of the things that was intriguing about Ørsted's experiment was that Ørsted discovered that when current went down a wire, it would force magnets to point in a circle around the wire. For that reason, Ørsted decided that the current wasn't going down the wire, but actually was instead spiraling around the wire. In France, a man named Ampere read Ørsted's paper and started to do a series of experiments about electricity and magnetism. For example, Ampere determined that two parallel wires with current in it would feel an attractive force between them. Ampere's experiments were so influential, the current is measured in amps in his honor. One day, Ampere was thinking about Ørsted's theory that current was spiraling in a wire and wondered what would happen if the wire itself was spiraling. Ampere thus coiled up a wire in a helix and studied the magnetism created by the current. The next year, a young Englishman named Michael Faraday published his theory that we still believe today. The electricity is really flowing straight down the wire, and improbably as it seems, somehow creating a circular force field around it. He also stated that the force fields from multiple wires will work with each other in what he called compound action. For example, Faraday interpreted Ampere's experiment with the two wires that feel an attractive force as the compound action of the magnetic fields from the wires supporting each other. Mind you, Faraday didn't come up with the idea of magnetic force lines for at least another 11 years. Faraday also said that Ampere's spiral coil also demonstrated how the fields were additive from parallel wires. Faraday noted that a coil of wire with current in it acts identically to a bar magnet, albeit a weak one. Let's go back to William Sturgeon. Sturgeon's friends had helped him get a job as a lecturer at a military academy, and he gave up shoemaking entirely to focus on academia. Therefore, he had the time to read Ampere's and Faraday's papers and to try to recreate their experiments and see if he could bump them up a notch. One day, Sturgeon was experimenting with Ampere's coil by wrapping a coil of wire around an iron bar. To his surprise, the iron bar amplified the magnetic effects of the coil. Because the electricity in the wire makes the iron act like a magnet, this object is called an electromagnet. Let's take a moment to go over what a magnet is and electromagnet. A permanent magnet always contains the north and the south. A north and a north will repel each other, and the north and the south will attract. You can visualize this using the magnet and the compass. The north end of the compass will point towards the south end of a magnet and away from the north end. Permanent magnets can also attract certain metals that are not magnets. For example, if a magnet is placed near a paperclip, the paperclip will be attracted to the magnet. This is because the paperclip is made of steel, and steel is composed of little magnets, or magnetic domains, that are randomly arranged. When the paperclip is near the magnetic domains line up, making the paperclip into a temporary magnet, where the north of the paperclip is attracted to the south of the magnet. You know an object is a magnet if it attracts and aligns metal paperclips. Now let's talk about an electromagnet. An electromagnet is a coil of wire wrapped around an iron bar. Without current, the bar will not attract paperclips or act like a magnet at all. However, if current runs through the wire, then the magnetic fields in the wire align the magnetic domains in the iron bar and make it act like a magnet with a north and a south. The bigger the current, the stronger the magnet. Amazingly, if the plus and minuses connection to the battery switch, the north and the south of the electromagnet switch as well. Also, once you disconnect the battery, the iron stops being a magnet. In 1826, William Sturgeon found that if you wrap wire around a U-shaped bar, he could create a U-shaped magnet. It was so strong that even with the weak batteries at the time, and with just a few turns of coil, an electromagnet could hold 9 pounds of weight, and then drop it dramatically when the current was disconnected. Sturgeon was awarded a silver medal for this discovery, as well as 30 guineas. At the time, everyone thought the big advantage of electromagnets, theatrical demonstrations. However, it turns out that a magnet that one can control electrically is far more influential and useful than anyone supposed at the time. Electromagnets were used in the invention of telegraphs, induction, telephones, generators, radios, X-ray machines, oscilloscopes, televisions, and radar. Back in 1820, Michael Faraday read about Sturgeon's device and made his own version, a double coil on a single ring of iron. He didn't know it, but he had made the first transformer. He kept this ring in his pocket for years, until 1831, when he used it to discover electromagnetic induction. I will talk about that amazing discovery in video number 20. But first I want to talk about another immediate repercussion of Sturgeon's electromagnet, the magnetic telegraph. See, in 1830, a paper about Sturgeon's device made it all the way to the backwoods of New York State. A bored math teacher named Henry Joseph read about it and invented the telegraph. Then a racist egoist named Samuel Morse, like Morse code, stole his idea and fame. And that crazy story starts next time on The Secret History of Electricity.
Electricity, 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 electricity.